Hello guys, this is Emma from MindMajix, and I welcome you all to this special session in which our trainer will explain everything you need to know about the OKTA. In this video, let us look at the topics we will cover. We shall start with the concepts of OIDC flow and continue with components of OIDC. Please check the caption to jump between the topics. If you are new to the MindMajix channel, please subscribe and press the bell icon to get quick updates about the new tech tutorials, free webinars, and career-enhancing shots from working professionals. Like and share the video with your friends and IT career aspirants. Without any further delay, let's start the video.
Today we'll start off with the OIDC as well as OAuth flow. We'll look into what OAuth and OIDC is all about, and then we'll move forward to the admin UI of Okta. So basically, right now we have covered what a single sign-on is, and under single sign-on protocols we understood there are different single sign-on protocols which include SAML, OIDC, WS Web, Secure Web Authentication, and today out of those we are going to see OAuth because we have already seen SAML. We have already gone through the SAML content. Now we are going to see the OAuth or the OIDC's SSO protocol. So these two, basically SAML and OAuth, they are the kind of standard protocols, and they are being mostly used in for the single sign-on practices, whereas secure web authentication or WS Fed or WS Trust, there are some of the protocols which we don't use much when compared to when compared to SAML and OAuth or OIDC protocols. So basically, if if I have to define what OAuth 2.0 is all about, why we are going to study OAuth first before OIDC is because OIDC is kind of an extension of OAuth only. So it's necessary that we understand OAuth first, and then we'll move on to the OIDC protocol. So OAuth is an authorization framework. This is a very important thing to remember because this has been often asked in the interviews that what kind of a protocol it is, whether it's an authentication or an authorization. Your SAML is an authentication and your OAuth 2.0 is an authorization framework. So it basically enables the application to obtain limited access to the user accounts. So, once you're authenticated, there has to be a limited access for each user in a particular application. So that's what it enables the applications to obtain limited access to the user accounts on a HTTP service such as Facebook, GitHub, or DigitalOcean or any other application. It works by delegating the user authentication to the service that hosts the user account and authorizing the third-party application to use the access the user account. OAuth 2 provides the authorization flows for web and desktop applications as well as mobile devices. So basically what it is doing is it is there will be two-way contact. One would be the user trying to access the application, and then another would be application trying to access the user information. Now both of them would be delegated, a user will not have full access to the application. That's where the roles or the authorization part would come into picture, and then the application itself wouldn't have the complete information about the user. So again, kind of limited or certain information would be granted. So that's what OAuth 2.0 is all about. Now if you want to understand the roles of OAuth, then it basically defines us 4 roles, one of which is resource owner, then we have a client credentials, then we have resource server, and then the most used one is the authorization server. So basically, before I move on to these flows, and we basically understand what are the different types of flows which we have under OIDC, I would rather like to go ahead and have a go through on the terminologies of what we have in OIDC. So very first terminology or the very first acronym which we need to understand is the resource owner. So the resource owner is the user who authorizes an application to access their account. So the application's access to the user account is limited to the scope of an authorization granted. So basically the resource owner is going to be the end user who is who wants the application to be authorized, or who authorizes an application to access their account, and then who is basically trying to get into an application based on their roles in the application. So they are basically trying to authorize an application based on their account permissions, And once the application's access to the user account is limited to the scope of the authorization granted. So, there are scopes which we'll understand, later, but like right now, you can think scope is something which will help the application to understand what level of permission the user has, whether it's a read, write, or, edit, modify, what level of permission it has. So, basically the application's access to the user account is being limited through a scope of the authorization granted. That could be either read or write, or, both, whatever access the scope says. So that's basically the resource owner. Now we have an authorization server or an API. This is an important thing to understand. So the resource server hosts the protected user accounts, and the authorization server verifies the identity of the user, then issues the access token to the application. So basically, what happens is that we have a resource owner, then we also have a resource server. Now that resource server is going to host the protected user accounts, and the authorization server is going to verify the identity of the user, and it will issue the access token only once the identity has been verified. So, basically your authorization server is going to authenticate or, verify the user. It's not directly authenticating the user, but it's kind of, it has to understand, or it has to, check whether it's a legitimate user trying to get into the application. So kind of a pseudo authentication which will happen. Once it's satisfied that, yes, it's a legitimate user, then it will, grant you an access token, and then, you can go ahead and, access different resources which we have under the application. So from an application developer's point of view, a services API fulfills both the resource and the authorization server roles. We refer to both of these roles combined as the service or the API role. So, basically this fulfills both the resource and the authorization server roles, and, we can combine them and we can term them as the service or an API role. Then we have a client, which is an application. So client is the application that wants to access the user account. Before it may do so, it may be authorized by the user, and the authorization must be validated by the API. So basically the client, or, the client or the browser, or, it's an application which wants to access the user's account. So whatever user is trying, whichever user is trying to get into the application, the client is the one which wants to access the user's account. And before it do it, it will do it, it has to be authorized by the user. Authorizing means the user has to grant the permission. I mean, an application cannot directly get or, access the user's account without being asked. So, you can take an example. Whenever you install a new application, so you are being asked whether, you want to allow notification, you say yes or no. You are being asked if you want to access, you want the contact list to be accessed by the phone, you say yes or no. I mean, to be by the application, you say yes or no. So all of these pop-ups are something, which, like, the application wants to use users information, but application will ask the user whether it can do it or not. And now it's up to the end user whether they allow it or not. If they are granting them access, then they are saying yes, you can. If they are not granting them access, then they are saying no, you cannot. So that's how it works. Next, some of the other terminologies which we have in OAuth are, one is the redirect URI. So basically the URL, the authorization server will redirect the resource owner. Resource owner is the one, who is going to be authorized, and basically the end user. It will redirect the resource owner back to after granting permissions to the client. So, so basically the redirect URI is something we have understood what is the authorization server. It's basically, going to verify the identity of the user and then provide an access token. Then resource owner is something, who is trying to, it's basically the end user's account. And then the client is the application that wants to access the end user's account. So basically the redirect URL is something, the URL that the authorization server will redirect to the resource owner back to after granting permissions to the client. So resource owner is going to grant permissions to the client, and then the URL, the authorization server, will redirect back to the resource owner. So this is sometimes referred to as the callback URL. So what will happen is that the resource owner is going to grant permissions to the client, and once it has granted permissions, it will redirect back to the authorization server, and that URL which redirects back to the authorization server will redirect it to the resource owner, which in turn will, redirect to grant the permissions to the client. So this is basically a callback URL. Then there is a response side, the type of information on the client expects to receive. The most common response type is code, where the client expects an authorization code. So, response type is something like, it could be your identity token, it could be your access token. I mean, something which you are expecting back in response. So, basically the most popular thing to expect back is a code. Basically we mostly use authorization code flows in when we talk about OIDC. So, that's where we get a code in return, and that's your response type. So the type of information that the client expects to receive, and the most common response type is the code, where the client expects an authorization code. Then scopes, these are granular permissions the client wants, such as access to data or to perform actions. Then consent is something the authorization server takes the scopes the client is requesting and verifies with the resource owner whether or not they want to give permission to the client or not. So, basically whenever you are granting permission to the client, whether they can access something or not based on the scopes. Scopes are, your granular permissions, which is trying to get the user's information. So if you're granting them your consent to have your data being read or written by the client, that is your consent, and that is something we can term it as consent. Then you have a client secret. So this is a secret password that only the client and the authorization server know. So, this allows them to securely share information privately behind the scene. So, client ID and client secret is something which we require in order to, verify our identity in front of by the authorization server. So that's kind of a secret password that only the client and the authorization server knows, and this allows them to securely share the information privately behind the scenes. Then an authorization code is a short-lived temporary code the client gives the authorization server in exchange for an access token. So whenever you get an access token, you have to provide an authorization code, and then only you are being granted an access token. Then if we talk about access token, the key the client will use to communicate with the resource server. This is like a badge or a key card that gives client permissions to request data or perform actions with the resource server on your behalf. So once your identity has been verified, and you have granted permissions to the client, now an access token is being granted. Now once you get an access token, it as the name suggests, access token. So you are basically going to, in that particular token, you are basically going to have what all access you have to or what all resources you have to access on an application. So that token will help you get through to whatever scopes or whatever access you have within the application. So basically we can think of it like, you go to a fair, there are you purchase a ticket, and in that ticket you might have 3 or 4 swings which are free of cost to you, right? You cannot definitely have all swings for free of cost, but you might have maybe have purchased a 500 rupees ticket, and you might have 3 or 4 swings which are free of cost for you. So you can go one by one and have the access to those swings. So similar is the case with the access token. Once the access token is granted to you, so whatever are the permissions you have based on your roles or based on your profile, you can go ahead and request for the access of those particular resources. So that's where access token helps you to it. So basically, if we want to understand the abstract flow of the OAuth 2.0, so basically you have an application that is your client, which actually makes an authorization request to the end user. Now, as a user, you are going to grant them your consent. That is, the authorization grant is being granted, and then once it's being granted, the authorization server provides an access token. And once the access token is you have been granted an access token. So this is basically your ticket counter, and this is basically your swings. Once the access token is being provided to you by the resource server, then you can go ahead and access anything in the resource API, or the service API or the resource server. So whatever are the protected resources you have, and whatever access you have got based on your access token, you can go ahead and actually access those resources. So now, if I talk about application registration, before using OAuth with your application, you must register your application with the service. This is done through a registration form in the developer or an API portion of the services website, where you'll provide the following information. So basically, I am also going to show you like how do we okay, yeah. So I'll just show you that how do we register an OAuth 2.0 application in Okta. So, in the meanwhile, the environment sets up. Okay, so basically this is, what we are going to do. We'll go to the applications, and we'll just go ahead and we'll go to the OIDC one. And over here we need to select, what type of an application we possess, or we are trying to integrate it. So most of the cases we are going to use a web application. My First Oauth app maybe. And over here you have the grant type. So this is something, the types, or the the roles, or the flows in which we can have an OIDC or an OAuth being set up. So you have client credentials, authorization code, or refresh token, or implicit type. And over here you have to give the redirect URI. So we just mentioned back here what is a redirect URI. Then you have to give what is the redirect, I mean, sorry, login redirect URIs and logout redirect. This is kind of optional, but this is something you need to give, because this is kind of once you have been authenticated, so it sends back the response to this particular URI. So you need to read this URI in order to get access to the access token, and then finally to the resource server. So you just maybe I'll just give the default URLs whatever we have. And this is something, if the request is coming from some other domain, like basically this is my domain right now, and if the request is coming maybe from SharePoint, or somewhere else, like outside of this particular domain, I have to add it over here in the trusted origin domain. So that's pretty much it. And once maybe, okay, we'll just skip the assignments of people for the time being. And once once my application is registered with Okta, now this is something I need to provide this to the application team. So whatever is the application name, let's suppose we do have an application with this name, then I do have to provide them the client ID and the client secret. And this is where I am, like, if I want to understand this thing. So this is an application, this is an end user who is trying to get into the application. Now this particular application will be corresponding, or you will be communicating to the authorization server or the resource server. And these two things is something which will be provided by Okta in our scenario. So basically an application request will go to the user. From the user it will grant the access. From access it will ask the authorization server to give them the the access token. Once the access token is being granted, it will go to the resource server and finally access the resources. So this is how an abstract flow looks like. And for us to do so, we require the application to be registered with this identity provider, which in our case is going to be Okta. We have registered that. Once we register it, we need to provide the client ID and the client secret to the application team. So basically this is something they are going to authenticate themselves over here. Once they get this authenticated, or verified by the authorization server, it will grant them the access token. So this is something we have to do for the registration part. So that's what we have written here, that before using OAuth with an application, you must register your application with the service. This is done through a registration form in the developer or API portion of the services website, where you will provide the following information, which is the application name, application website, redirect URL, or the callback URL. And redirect URI is the service which will redirect the user after they authorize your application, and therefore the part of your application that will handle the authorization code or the access token. So basically once you have given your consent or not given your consent, based on your response, it's going to be the URL where the authorization code and the access token is going to be granted, or you are going to get that token or a code at that particular URL. And once you get that, you need to extract that code or an access token, and then finally go to the resource server with that code, saying that it's kind of a ticket. So wherever you can receive your ticket, it's kind of that particular URL. So once you receive your access token, you are going to the resource server to asking them that I require these resources to be accessed to, and they'll check whether you have an access token. Whatever access token says that you have access to, you'll be allowed to get access to all of them. So that's what it is, and that's what your registration of an application is. So once your application is registered, the service will issue a client credentials in the form of a client identifier and a client secret. So the moment you remember, you would have seen that we clicked on save, our client ID and client secret were generated. So moment the application got registered, the client ID and the client secret got generated. And client ID is a publicly exposed string that is used by the service API to identify the application. So basically this is kind of in entity ID. We studied, what is an entity ID in SAML. It's kind of a unique attribute or a unique value which, differentiate or distinguishes an application from other application. So that's what the client ID is all about. So, it's basically the application. What is a client? Client is your application and it's the identifier of the application. So, basically that is what the client ID is all about. And once you get your identifier generated, you need to, it's being used and it's being exposed publicly, and it's being used by the service API to identify the application, and it is also used to build the authorization URLs that are presented to the user. The client secret is used to authenticate the identity of the application through service API. When the application requests to access a user's account, it must be kept private between the application and the API. So basically, over here, the application is going to be authorization server with the client ID and client secret. And over here, if this is a legitimate and if it is being verified between these two entities, then only you are being granted an access token. So that's why it has their client secret has to be, kept as private between these two entities. It cannot be, made public. So because if it is made public, then anyone can go ahead and make a connection with the authorization server, and they would be requesting for an for a for the authorization code or an access token, and based on your client ID and client secret, that would be granted. So we need to be extra cautious that our client secret should not be shared with anyone. Okay, so now next, we are going to see the different types of grant types which we have in OAuth 2.0. So the very first and the most used one that we have is the authorization code flow. So you have the resource owner, that is the end user. Then you have an application. Then finally an authorization server and your API. So basically I'm talking, if I have to refer to this, I'm talking about application, user, authorization server, and the resource API, right? So I'm basically covering all of that. So now, what happens is that, if the user goes to the application, so it will click on the login link, it will go to the application. Now from the application, the user requests the authorization code to the auth server. So, over here, the client actually does not directly go with the client ID and the client secret. Instead, it will request for an auth code from the authorization server. Once the auth code is being requested, the authorization server redirects to the login / the authorization prompt. It will redirect you back to the user. And over here, now the user is being asked, okay, that this particular application is requesting access to this thing. Would you grant access or not? You will say yes or no. So, you are eventually going to provide your consent to that request being generated. If you authenticate and consent is being provided, then the auth code is being provided by the authorization server to the application. Now the authorization code is there with the application. Client ID and client secret was something which the application already had, because your application, once the application was registered, you had already provided that client ID and client secret to your application. So now authorization code is something which is being granted when the user gave its consent, and client ID and client secret is being provided already to the application at the time of application registration. So now the application is holding three data points. That is, one is authorization code, one is client ID, and the other is client secret. So now it will go back to the authorization server. It will validate the authorization code as well as client ID and the client secret. If all of these three are being validated by the authorization server, it will provide you the identity token and the access token. Now, identity token would be granted if we are talking about OIDC, that is your OpenID Connect. If you're not talking about OIDC, then just remove this identity token and only access token would be granted. And that's what the difference between this OAuth 2.0 and OIDC is. So basically in OAuth 2.0, you do not have a login screen. In OIDC, you have a login screen, and when you're trying to get into the application, you are being provided with an identity token as well as with the access token. So that's what the difference between these two flows are. I mean, these two protocols are. We are going to eventually see in detail a little bit more on what OIDC is. But now wherever that authentication is, direct authentication is coming into existence, that's where your OIDC is. And if it's like a pseudo authentication, so it's kind of then your OAuth 2.0. Let's suppose that you did not have a login screen over here. Then also there would have been some validation, right? Validation of client ID and client secret. So what is a validation? It's kind of an authentication only, right? That you are going in with your client ID and client secret authenticated by your authorization server. Now over here, you are having a login screen. So that's where, like, as an end user, you are thinking you are doing a login. So that's why OIDC is an authentication protocol. But in OAuth 2.0, you are not doing a login. You do not have a login screen. So you are eventually going to do authentication in a pseudo manner. End user doesn't know that. So your application is eventually going to do that authentication. You as an end user does not have to authenticate. You only have to grant permission. But in OIDC, you as an end user have to authenticate. So that's the difference. So would you have been provided with the identity token and the access token once it validates the auth code, ID token, and the access token. And once the request, now with all of this data, once everything is being provided by the authorization server, that is your ID token and access token is being granted. Now the app requests the user data with the access token. So it goes to the API server. This is the server which is holding all of the information about the user. So the application or the client will go to the resource server or an API server, and it will request for the user information. Whatever in the access token it has, it will just send back the response to the application. And that's how your authorization code flow works. So only thing is that in the authorization code flow, that you get an auth code first, and once you get an auth code, you validate your auth code, client ID, client secret with your authorization server, and only after you validate with your authorization server, you are being able to get the identity token as well as the access token. So this is basically the client, the flow which is being mostly used in case of web applications. And over here, when I selected this thing, right, when I went into this, and I had to select what type of an application I'm trying to integrate. Maybe I'll just so I'll just, over here, once I selected OIDC, I had to select, whether it's a web application, single page application, or a native application. So we have different flows or different, grant types as per the use cases we have for the application. So if it's a web application, 95% of the times you will see that, you'll use authorization code. If it's like a single page application, then, you might be using implicit, grant types, which we are going to see now. So basically, based on the grant types, we are going to see, what type of, based on the application, sorry, based on the application, we are going to see what type of grant type we have to, go ahead with. Next comes the, the client credentials grant type. Now in this scenario, there is no user, so basically what happens is it's like machine to machine authentication. So you have a machine which is trying to authenticate itself and, or authorize itself, and there is no end user. There is no end user to give consent or stuff like that. So just think of it same thing, but this end user is gone now. So that's your machine to machine authentication, that is M2M. You have an application or a client, then you have an authorization server, and then you have your API. So basically the machine is going to go to the tenant or the authorization server with the client ID and the client secret. It will validate, the authorization server is going to validate your client ID and client secret. Once it validates, the access token is granted. It will request data to the API server with the access token, which is granted. And finally, the API server is going to send back the response to machine or your application. So, it's very simple. The only thing is that there is no concept of authorization code, or there is no concept of user over here. So, there is no resource owner or the end user. So, it's your application or the client which is directly, communicating. So it's basically wherever there is no intervention of the user, and sometimes, you require APIs to be authenticated via OAuth. So at that point of time, we require, machine to machine credentials or the client credentials grant type. Then we have the implicit flow. Over here, you again have a user, you have a client, you have an authorization server. But over here, you don't have the API server or the resource server. So basically, as an end user, if you're using OIDC, you'll have a login screen. If you're not using OIDC, you're not going to have a login screen. The user will go to the application. From the application, it will request a token, and once the token is being it will request for a token. It will redirect you back to the end user, or the resource owner, where it will ask you to authenticate and give your consent. Once you give your consent, it will provide you the token. So over here, the security wise, it is less, it's not very good, because you don't get an auth code and that is not being validated. It's exactly same what happens over here. The only difference is that over here you have an authorization code to validate as well. Over here, when the authorization server sends you back to the end user, over there you authenticate and give your consent, and you are directly being getting access to the application. You don't have an auth code, you don't have to validate again. At that point of time, it will just provide you directly the authorization, I mean the token. So your authorization server will provide the application the token, and you can just get into the application. So that's like for your single page or native applications, or your legacy applications, where the web application versions are not supported. At that point of time, just to have the OAuth, or the single sign-on protocol into picture, you can use this particular protocol. So that's what your OAuth 2.0 is all about, or the different grant types which we have in OAuth 2.0. Next, we are just, although we have seen what's the basic difference between an OAuth 2.0 or an OIDC, but we'll just read a little bit of what OIDC is all about. So it's an interoperable authentication protocol. I've mentioned why is it an authentication protocol, because you are getting a login screen to enter your password and credential, and then finally give your consent to. So that's why it's an authentication protocol rather than the authorization protocol, and it's based on the OAuth 2.0 family of specifications. So it uses straightforward the rest of the JSON message flows within a design goal of making simple things simple and complicated things possible. It's uniquely easy for developers to integrate when compared to any preceding identity protocol. So it lets developers authenticate their users across websites and apps without having to own and manage password files. For the app builders, it provides a secure, verifiable answer to the question, what is the identity of a person currently using the browser or native app that is connected to me? OIDC allows for clients of all types, including browser-based JavaScript and native mobile apps, to launch sign-in flows and receive verifiable assertions about the identity of the signed-in users. So basically, your identity authentication plus OAuth 2.0 is equivalent to your OIDC. So, you have an OAuth 2.0. If you add a layer of identifying and authenticating the user, that becomes your OIDC. That's it. Like that's the main difference between an OIDC and an OAuth 2.0. So it can also authorize, but the primary purpose of OIDC is to give you authentication. OAuth 2.0 also can do the authentication, but that's like a pseudo authentication. So primarily the work of, or the objective of OAuth 2.0 is to do authorization, and primarily the objective of OIDC is to do authentication. Although both can do both, but that's what the primary purpose is. So OAuth 2.0 is designed only for authorization, for granting access to data and features from one application to another. OIDC is a thin layer that sits on top of OAuth 2.0, and that adds login and profile information about the person who is logged in. Establishing a login session is often referred to as authentication, and information about the person logged in is, that is the resource owner, is called an identity. When an authorization server supports OIDC, it is sometimes called an identity provider, since it provides information about the resource owner back to its clients. So that's what the difference is. Like whenever you get the authorization server which sends back the information to the identity provider, it's the resource owner credentials flow that we have to use. OIDC enables scenarios where one login can be used across multiple applications, also known as single sign-on. For example, an application that could support single sign-on with social networking services such as Facebook or Twitter, so that users can choose to leverage a login they already have and are comfortable using. So basically you would have seen a lot of times, if you want to log into any application, you get an option, sign in with Google, sign in with Facebook. So that's basically most of the places you will see that that's OIDC being implemented straight away. Mostly wherever you will see sign in with Google, 95% of the times it's OIDC flow which is being implemented at that point of time. So it basically helps user, even you would have seen that I logged into this particular account. So if I just have to sign out and show you again, So I do, I go here and I sign in with Google. So this is basically an OIDC connection. What it is, I'm not directly using my username and password to get into. Instead, I'm using my Google's account. So that's where it my Google would have authenticated, and now I'm going to leverage the services of Okta. So that's exactly what OIDC is going to do. So it's the perfect example of the OIDC of how it works. So yeah, I don't have to create a separate password or credentials for my Okta. I remember my Okta and I remember my Google's credentials. I trust Google that it will, my security is not being compromised. And if I trust that, so I can just use my single credential of Google to get into the application instead of me creating different password again and again for different applications. So that's where if you see somewhere social logins, and if you trust those social logins, so you can use that. And eventually what are they doing? They're using OIDC. That's the case what we are trying to understand. So it's basically an OIDF standard that profiles and extends OAuth 2.0 to add an identity layer, creating a single framework that promises to secure APIs, mobile native applications, and browser applications in a single cohesive architecture. It adds two notable identity constructs to OAuth 2.0 token issuance model. One is an identity token. You don't have an identity token in that OAuth 2.0. So identity token is something you get when when we talk about OIDC. And the other thing when we is that you get a standardized identity attribute API at a client, which can be retrieve desired and identity attributes for a given user. So what problem does OIDC solve? OAuth 2.0 is not an identity protocol. It's an authorization framework for securing arbitrary APIs as opposed to APIs fronting identity information. So it's basically your OAuth 2.0 is your authorization framework, whereas your OIDC is kind of an authentication framework. So that's where we require OIDC to be brought in on top of the OAuth 2.0. So if I have to compare between OAuth and OpenID Connect, so if I have to compare between OpenID versus OpenID Connect, so OpenID is your open standard for authentication being developed by the members of OpenID Foundation, whereas OpenID and the problems which we face with OpenID 1 and 2 was that the URI as the identifier were too hard for the people to remember. So not API and mobile friendly, and no support for robust signing and encryption. And whatever the enhancements that came into existence, that actually were treated as the OpenID Connect. So that was the main difference, although this is not very important for you to understand in the fundamentals part, so that's fine. And if you need to understand the basic difference between OpenID, OAuth, and finally SAML. So in OAuth 2.0, the token or the assertion that is being generated is in the form of the JSON or the SAML 2.0, or XML format, you could say. OpenID, it's completely in JSON format, and SAML, it's in XML format. OAuth 2.0, yes, it's an authorization protocol. OpenID, no. SAML, it's an authentication, but sometimes it can allow you to do authorization, but it's like it's very restricted or limited. You cannot achieve authorization with SAML up to a great extent. Authentication, I did mention that it does pseudo authentication. So OAuth 2.0 does a pseudo authentication. OpenID, yes, definitely it's an authentication protocol. SAML, yes, it's an OIDC. I mean, SAML is an authentication protocol. Then for the transport layer, you use HTTP for OAuth 2.0. For OpenID, you have get HTTP post, and so you basically have HTTP get and post methods for OpenID. For SAML, you have get binding, and then you have SAML SOAP bindings, and post bindings. So you've got multiple bindings under SAML. Security risk is risk. If we talk about OAuth 2.0, it's the phishing. So OAuth 2.0 does not support signature encryption or channel binding or client verification. So instead, it relies completely on TLS for confidentiality. So you would have seen that it's not client ID or client secret is something being provided by the by the end user or the identity provider who has registered the application. It's not something client has something unique on its own. So it's not verifying the identity of the client. So that's where a lot of phishing attacks happen when we talk about OAuth 2.0. OpenID, also there are phishing attacks. Identity providers have a log of OpenID logins, so making a compromised account a bigger privacy breach. So basically whenever there are two parties, because now there is an identity provider keeping a log of whatever the OpenID logins are. So it's kind of a data or a security breach. Then if we talk about SAML, so XML signature wrapping to impersonate any user. So, there could be a signature which can impersonate that you are not a legitimate user. Instead, you can impersonate to become any user. So that's again a security risk. OAuth 2.0 is basically the best suited for API authorization. OpenID is best suited for single sign-on, and SAML is also best suited for single sign-on. So that's pretty much it. And that's, I know like it's a little bit difficult to understand OpenID, but like we just try to cover the fundamental parts of what OIDC and OAuth 2.0 is all about. I would request if in case something is not clear, just try to revise the session again, and just try to look at the flows I have mentioned in this particular video. And if in case any doubts are there, maybe we can have another session on OIDC. So yeah, that's it from my end for today. Thank you everyone. Have a good one. Bye bye.